Okay, calculus. We are at a massive kind of concept right now. The net change theorem is a very, very large piece that we continue to use for quite some time. And it really says the net change or the displacement is as follows. The integral from a to b of the velocity function is equal to the position or the displacement. So for example, if you have just a number line and we say that this position is 1 and this position is 8, if an object starts at 1 and it goes to 8 and it comes back around, we would say that that net change is 0. But we would say the total distance is 14. So the displacement or the net change in that situation is 0. And what we need to be given in that situation is the velocity function. And when you take the antiderivative of the velocity function, it actually gives us the position or the displacement, which is pretty cool. If you want the total distance, so you can see in that example that the distance is actually 14, then that would be the integral a to b of the absolute value of the velocity function. That's equal to the distance traveled. Forgot a dt over here. So this is a three video lesson. So we're going to just start basic today. It says particle moves at a velocity modeled by the function v of t is equal to t squared minus t minus 6. I'm going to graph that first. I see this factors to t minus 3 into t plus 2. So in other words, and again, this is the velocity function. We're going to see what we can tell about the particle by looking at this guy. Goes through -2, +3. It's parabolic, goes like this. So this is the velocity function. So I know that the object is traveling to the right here because the velocity is positive. It sits above the x-axis. And then the object is traveling to the left here because the velocity is negative. It sits below the x-axis. So these are the pieces that I currently know. It says find the net change or the displacement of the particle over the interval 1 to 4. Okay. The net change is the integral from 1 to 4 of the velocity function. Or the integral 1 to 4 of t squared minus t minus 6 dt. We know how to evaluate that very easily. Antiderivative of t squared is t cubed over 3 minus t squared over 2 minus 6t. We're going to evaluate that at 4 and 1. When we plug in 4, we get 64 over 3 minus 16 over 2, which is 8, minus 24. Minus, and then we're going to plug in 1. 1 over 3 minus 1 over 2 minus 6. So as we join some terms here, 64 thirds minus 1/3 is 63 thirds, or 21. Those are gone. -8, -24, will be a +6 and a +1/2. Okay, so we'll work this out. 21 minus 8, that would be 13. 13 minus 24 would be -11. +6 +1/2. So -11 plus 6 is going to be -5. +1/2 is -4.5, or -9 over 2. That's the displacement. So what that means is, suppose that the object started, which we don't know, but suppose it started at 0. It moved to the left, we know, and then moved back to the right. And it moved back to, say, negative 4.5. Doesn't mean it traveled the total distance of 4.5, but it means it's located 4.5 units from where it actually started, and it's located to the left. Now, we would actually like to find the total distance. Now, this may seem challenging to think about, but it's really not bad at all. What we do is we do the integral from 1 to 4 of the absolute value of v of t dt. And in other words, what we do is we find where we have distance to the left and we add that to distance to the right. So if you look here, you can see that from 0 to 3, we have distance to the left. And then from 3 to 4, 4 is where our interval ends, that's where we have distance to the right. So we're going to find our distance to the left, which is the integral from 1 to 3 of t squared minus t minus 6. I think I got that right, dt. That's our distance to the left, and we add that to the distance to the right. Integral from 3 to 4, t squared minus t minus 6 dt. All right, we already know the antiderivative, t to the third over 3 plus t squared over 2 plus 6t, evaluated 3 and 1. Plug in 3 to the third is 27, divided by 3 is 9, plus 9 over 2, plus 18, minus, now I'll plug in 1, I get 1/3, plus 1/2, plus 6. So let's see what we come out with here. 9 plus 18 is 27, minus 6 is 21, so I've got rid of those. 9 halves minus 1/2 is 4 halves, or 8 halves, so minus 4, excuse me, plus 4. And we have minus 1/3. So we have 25 minus 1/3. So 25 is 75 over 3, minus 1 over 3 is 74 over 3. So that's what we have right now. That is our distance to the left. I thought I made a mistake there. That didn't look right at all. Why? Because distance to the left should come out to be negative. So if you look right here, I don't know why I put the plus signs there. They're obviously negative. So minus t squared over 2 and then minus 6t. That'll produce a better value. Let's try that again. So we get 9 minus 9 over 2 minus 18. And then 1/3 minus 1/2 minus 6. That looks better. 9 minus 18 is negative 9. And then plus 6 will be negative 3. Negative 9 halves minus a negative 1/2 will be negative 8 halves, or minus 4. And then we have a minus 1/3. So negative 7 minus 1/3, or negative 21 over 3 minus 1/3 is negative 22/3. So what this tells us is the object goes to the left direction. You can see from a graph right away, it goes in the left direction, so it travels negative 22 over 3. Okay, and again, so we're going to count that distance as positive, because you can see that we take the absolute value. You see this absolute value sign means we make those distances positive. So 22 over 3 plus, and now let's figure out what we get over here. We have, again, t cubed over 3 minus t squared over 2 minus 6t, evaluate it at 3 and 4. 64 over 3 minus 8 minus 24. Now I plug in 3 and I get 9 minus 9 over 2 minus 18. (64 over 3 isn't really going anywhere. Let's see here, I could add a 9 halves. So those are gone. But now I have negative 8 minus 24. That's, let's see, negative 32. Minus 9 is negative 41. Negative 41, and then I'm going to add 18. 41 plus 18. What is that? Negative 23. So minus 23. Common denominator of 6. So 128 over 6 plus 27 over 6 minus, let's see, 23 times 6. And I get 138. So 128 plus 27 minus 138, and that is 17. 17 over 6. So I take the 22 over 3 and add it to the 17 over 6. And 44 over 6 plus 17 over 6 is equal to 61 over 6, which is 10.16 repeating. And that's what we get there. And we can actually check these results here, which is kind of nice. If you went in and you went to y equals here, and you typed in that velocity function, t squared minus t, or x, minus 6, and you went ahead and you calculated number 7. I'll do a zoom 6. We're going to calculate number 7. We're going to do it from 1 to 4. 1 is our lower limit. 4 is our upper limit. Notice you get the negative 4.5, which is what we have right here. Well, what if we do the absolute value? Well, I'm going to show you something cool here. If you do absolute value, I think maybe is it math? It doesn't matter. I always like to go to catalog. Go to your catalog, hit ABS. Whoop. Go down here. Absolute value of, and then you can actually grab Y1. So if you hit vars, V-A-R-S, it's right above tangent, and then go over to Y vars, press enter on function. You can grab your Y sub 1. So what it does, instead of having to retype everything, it's going to take the absolute value of that Y1 piece. And so, well, first of all, look at the graph, because the graph is really cool. Notice it keeps it above the x-axis, which is what you want it to do, because it's the absolute value. And then when you calculate number 7, the lower limit is 1, and the upper limit is 4. Look at, it's going to find that area. It's a little bit challenging for it to do it, but 10.16, there you go. It comes up with an approximation. We know the exact value is 10.16 repeating. But yeah, so anyway, there's the net change theorem. We got 3 days of this stuff. It's a really, really big idea, and this is the basic of the application. Again, in terms of your displacement versus your total distance. Whether you take the integral of the velocity or the integral of the absolute value of the velocity. And then we're going to apply it to other situations. Have a great day.